Hello, anthropology students, and welcome to our first biological anthropology lecture of the semester. I will start off with just mentioning my background. I have been teaching anthropology, specifically biological anthropology, for a long time now, about a decade, and I'm teaching all around San Diego, at Miramar and Mesa and Grossmont. I've taught this course at UC San Diego, up at Maricosta and Saddleback, so lots of colleges and universities around San Diego. My background, my education, my graduate education was at UC San Diego, where I got a master's degree in anthropology, and my PhD in biological anthropology is currently in progress. My research, my specialty for my graduate studies was studying chimpanzee social behaviors. So I got to spend a year living in the jungles of Cavale National Park, chasing chimpanzees around in the forest. So that was a very good year. I've also studied the bonobos that used to be at the safari park, some monkeys, some macaques in Sulawesi, Indonesia, some gorillas at a zoo in Albuquerque, and I've done some time looking for fossils of primates in the deserts of New Mexico and Colorado. So that's my background, specifically primate behavior. So that's why you'll see in the schedule, we spend about a month talking about primates because I like them so much. And we will spend 1 week on chimpanzees. You can see that in the schedule. I believe that's week 7. That's the week I really know what I'm talking about. The rest of the semester, I'm just trying to sound like I know what I'm talking about. Okay, so that's me, that's my background, but you guys are here for anthropology, specifically bioanthropology. So let me tell you a bit about that. This is a plan for the week. By this point, I think you all have probably already seen the welcome video in Canvas, where I sort of gave a course introduction and went through the syllabus and showed you around the Canvas site. So you know, should know basically the basics about this course. So what this lecture will be about is talking more specifically now about the subject of biological anthropology. I'm going to give you a little bit of background and context there. And then we're going to get into talking about science in this lecture. And this is all set up for a discussion of evolution and natural selection, which we'll probably focus on more next week. So, anthropology. First off, I don't know how many of you have already taken an anthropology class before, but I'll start out with the basics. Anthropology is the study of people. You may have realized that people think a lot of themselves and they think they're very interesting and they find all sorts of ways to study themselves. Lots of disciplines in college are focused on studying humans. Anthropology is one of them. The term actually means the study of man or humans. That's a big field, right? There's lots of disciplines. Even within anthropology, there are sub-disciplines of anthropology to sort of break up the study of humans in different ways. And there's 4 main subfields. Biological, which sometimes in the past used to be called physical anthropology. Then there's archaeology, cultural anthropology, and linguistics. And as you know from what you signed up for, you are here in the biological subfield of anthropology. So one of the things we're going to get into later in the semester in our subfield is the interaction of culture and evolution, which we'll call biocultural evolution. That'll come up more later in a month or so from now, when we start getting into more complex primate behaviors and get into human evolution. But this semester, we are going to look at how biology and culture sort of influence each other, right? How biology makes culture possible, and how culture can influence biology. And just sort of for a preview, what I mean by biology making culture possible is that not all animals show evidence of having culture, right? There's not a lot of evidence showing squirrels have culture, right? Or rabbits or pandas, right? There may be some biological prerequisites, probably having a lot to do with large brain size. Basically, you need a big brain to have culture. So biology sort of sets the stage for culture. And then culture and those sort of learned behaviors that you see in animals and with culture can shape biological evolution in interesting ways. But again, we're going to get to this a little later in the semester. We'll build up towards this over the next few weeks. Okay, this is just a simple little overview of the subdisciplines of anthropology. Bioanthropology, we're going to look at human behavior and biology. We're going to look at the past, the present, living humans, dead humans, everything within the framework of evolution. We're going to look at dead and living people and non-human primates. So we're going to cover a lot in our discipline. Just so you know, if you have not taken any classes in the other subdisciplines, just if you're shopping around for classes this semester or next semester, so you know, archaeology is a type of anthropology. They focus on the things left behind from past cultures, right? And they use that to study social change through time. So their focus mostly is dead people. If you really like dead people, archaeology is a good subdiscipline for you. Culture anthropology is focused more on living people. That's looking at behaviors and ideas and beliefs and how people act and create meaning with their lives all around the world. I think everyone should take a culture anthropology class, also biological anthropology class, but if you have not already taken a culture anthropology class, you guys should. It has the potential to make you a better person, more broadly, globally aware person. And then the fourth subdiscipline is language. If you really like language, that's the subfield that specializes in that. It looks at how language and culture interact with each other. So that is the context that we are in, right? So here's our class, ANTH 102, Biological Anthropology. What makes biological anthropology different than the other subfields of anthropology is the emphasis and focus on evolution, okay? None of the other subfields necessarily have to take evolution into account. They sort of can if they want to, but it's not their primary focus. Biological anthropology, everything in this subdiscipline is founded in and grounded in evolutionary theory. So that's one of the main differences between the anthropology subfields. All right, so we're going to talk a lot about evolution this semester. Okay, so biological anthropology is itself a big subfield, okay? So we're going to look at some main parts of biological anthropology. So we're going to break up our course into basically 4 components. So if you're looking at the schedule for the semester, basically the first month is we're going to look at evolutionary theory and genetics. In this lecture, we're going to talk about how the scientific method is used. And next week, we're going to get into focusing on how evolution by natural selection works. And then the week after that, we're going to get into genetics. So that's like the first month of the class, science and evolution and genetics. Then, sort of the second month of the class, we're going to get into talking about non-human primates, right? That'll be in September when we get to this. This is my favorite part of the class because I love primates. So we're going to look at primate bodies and primate behaviors and understand them in the context of evolution. And we're going to figure out why we're studying non-human primates like monkeys in a class and a discipline that's about studying humans, right? What is the point of studying other primates? How can we use them to learn more about humans? So that'll get us to about the halfway point in the semester. Then we're going to have about a month looking at human evolution. We're going to look at our fossil ancestors, those weird bipedal apes evolving in Africa and moving around the world. We're going to look at how natural selection and evolution shaped their bodies and their behaviors. And we're going to be building up to how, when, where, and why our species evolved, right? And what makes us similar to these earlier species and what makes us different. Then, once we get Homo sapiens, which is around beginning of November, then we're going to spend a month talking about Homo sapiens. We're going to look at like human variation. We're going to look at aspects of the life cycle, like lifespan and childbirth and things of that nature. We're going to look at intelligence and mental abilities compared to other primates. And we're going to look at biological variations between different groups of people. So that is the plan for the semester. And, broken up roughly by a month for each of those disciplines, of those focuses, areas of focus within our subdiscipline. There you go, that's our schedule. All right, so what I need to talk about. Okay, so visually, if you want an easy way to think about this semester, what we're doing is we're starting here with basically like rodents, okay? This is the beginning of the semester, and we're gonna work our way through to Homo sapiens, you. That's where we'll end up at the end of the semester. So we got to go from here to here in 4 months. Do you guys know how do we get from rodents to you? What is the process that gets us from the beginning of the semester to the end of the semester? You may be able to guess what it is. This would be evolution. Okay. Evolution is the biological process we're going to talk about all semester long, that's bringing us from rodents all the way up to you guys sitting and listening to this lecture. Okay, so evolution. Like I said, we're going to talk about evolution a lot. So all of the biological sciences are based on the theory of evolution by natural selection, right? This means any bio class you take in the biology department is based in evolutionary theory. You signed up for an anthropology class over in the humanities and social sciences department, right? But this is biological anthropology. And as I mentioned before, what makes biological anthropology different from all the other subdisciplines is the use and focus on the evolutionary perspective. That's why I've started talking about evolution today, and I'm going to talk about it every week for the whole semester because you have signed up for a biology class. This is where you are. So I need to go over evolution and talk about it because understanding evolution is necessary for understanding everything we do in this course all semester long, right? All the readings, all the lectures, everything we're looking at is based and grounded in evolutionary theory. Okay, so like I've said a few times, I've been teaching this class for a long time, and I know at this point, some students start to get a little worried and like, oh no, I think I signed up for the wrong class. I shouldn't be here. This is not gonna work for me. Wait, I want to explain something before we push on from this point. I want to try to clear up any potential misconceptions that you might have. Okay, for this course, okay, for the context of what we're doing in this course, it makes no difference to me whether or not you believe in evolution, okay? Your personal beliefs are yours, okay? You didn't sign up for this class to learn about your personal beliefs. You've already got those. You come into this class with your personal beliefs, you're gonna leave with your personal beliefs. You know, they're yours. I do not care about your personal beliefs. You never have to tell me what they are. You don't have to justify your personal beliefs. You don't have to explain your personal beliefs. Never in an assignment am I gonna be looking for your personal beliefs about this. Doesn't matter in this class. What does matter and what I do care about is that you understand how evolution works, okay? Because that's what you need for this course. You need to understand it. Because like I said, everything we do is based in evolutionary theory. So that's what I'll be looking for in, you know, exams and assignments is, can you show me you have a good understanding of how it works, right? I will evaluate your understanding. I'm not going to evaluate you on your beliefs. Hopefully that makes sense, that difference between belief and understanding. If anybody has any worries about it or confusion about it, you can send me an email or we can bring up a discussion about it in the discussion board, but this is what I care about, understanding. I want everybody to understand evolution this semester in this class. And I should mention the sort of the flip side of this is, you know, I don't care about your beliefs. That means that believing in evolution is not going to help you pass this class if you don't also understand how it works, right? You know, you can never, you know, give me an answer on an assignment that says, oh, you know, I believe in evolution. I love it. I have a little Darwin fish in my car. Yay, Darwin. But I don't really know how to explain how monkeys evolved into humans. Like, nice for you. Sorry, fail. I don't care about your beliefs, just your understanding. Okay. And I bring this up because, like I said, sometimes students can get, you know, a little worried about this in the beginning of the semester. But I have had plenty of students over the years that come into this class not believing in evolution, and 4 months later they leave the class not believing in evolution, and they pass the class, they do well, sometimes they even really still enjoy the class, they have fun. It's fine. Okay. Hopefully everybody's all right and comfortable with this distinction. So, however, I am going to be discussing elements of religion and doing some contrasting with it, with science, because part of what we're going to do this week and next week is to distinguish different types of explanations, religious versus scientific explanations. So to start you off in thinking about the differences here, okay, is, you know, humans, with our big fancy brains, we like to try to explain the world and figure out how things work, right? We've been doing that for thousands of years. Religious explanations are a type of explanatory system that humans have, right? But they tend to, that system tends to function differently than a scientific system of explanations, right? Religious explanations tend to rely on belief and faith, and they do not rely on the same type of scientific evidence and testing, like we'll see talked about in the context of science. Okay? And I bring this up because, in the United States, a lot of people freak out about the, conflict between science and religion, and there's lots of tension and, fighting about it and all sorts of drama. And I think a lot of it is unnecessary because I think it comes down to not a very clear understanding of the differences of the two systems. Okay? So I have a few questions here to sort of bring up, try to help you understand what I mean by the differences here. Let's see. I have had, I've heard this idea before, and I've had students in class bring it up, this idea before, where we're going to be talking about fossils later in the semester, right? And we're going to be looking at those for about a month. So one idea when it comes to fossils, is that they are fake, okay? Fake news. Now there's, one version of this where, scientists are all getting together and faking their fossil finds and this sort of weird scientific conspiracy. That's not as really interesting for this discussion. A more interesting suggestion I have heard before is that the fossils are fake in that God created the fossils to trick people. And God put these, old looking rocks with funny shapes that look like animals, right? He set these fossils out to try to trick people of weak faith into abandoning their religious beliefs and, falling by the moral wayside. Okay, so, I had a student, bring that idea up one time early in my teaching career saying, God made up the fossils to trick people. Okay, that's an interesting idea. Now, that is a religious explanation for fossils, right? It's not necessarily a mainstream religious explanation, but it's a religious explanation for explaining fossils. Now, from a scientific point of view, how can science sort of deal with that idea, right? So my question here is when a supernatural explanation is proposed, right? And usually pretty much explanations involving God are by definition supernatural because of the powers that are attributed to God. Okay, how can supernatural explanations be tested and proved scientifically? So my example of the fossils, right? Okay, can you guys imagine what scientific tests would prove that God did not put the fossils in the ground to fool people of weak faith, right? If someone has the belief that God put those fossils there to trick you, can science disprove that? Can a scientist run a test and say, no, look, my test proves God didn't do that? That's a question I think we could try to talk about, right? If we were in the classroom, we could talk about it in class, but in this online class, I'm gonna see if we can play with that idea over in the discussion board, right? Help me out with this idea. What could a scientist do to test to prove that God didn't do that? Okay. Another idea that I've heard, and it's a very different religious explanation, okay, is that, how to phrase this? Okay, in this country, in the United States, there's a lot of drama with religion and science, but a lot of times it's mostly focused on biology, right? other disciplines of science don't seem to get into too much trouble with religious folks. Okay? There's not a lot of religious opposition to chemistry and physics compared to biology. So one of the reasons for that is that chemistry and physics can often have a compatible explanatory framework with religion, in that you can look at chemistry and physics and the mathematical equations you're getting out of that and the laws and rules and stuff, showing you sort of how God has ordered the universe, right? Chemistry and physics is uncovering the way that God has, ordered the interactions of the material world. Okay. So great. They don't cause a conflict with a religious view in that sense. So another possible religious type of explanation for biology is that, in fact, biology is also how God has designed animals to work. Right? Is that God set up the rules for nature, right? Inorganic things obey the rules of physics, interactions between inorganic things obey the rules of chemistry, and living things obey the rules of biology. They're all God's rules and God's method of organizing the universe. So if somebody presents that idea, right, and says, well, biology is God, right? God set that up, that's how God works, through biology. Can science come up with, again, testing or evidence to prove that God does not control things through biology? Can science prove, no, sorry, there's no way God can be involved in biology. It's gotta be two separate things, right? God can get involved in physics and chemistry, that's okay, but no. Science says there's no God in biology. So help me out with this question too, and give me some ideas over in the discussion board. Can science do that? Can science prove that God is not involved in the rules of biology? I've had conversations about these in class, so I want to see how they go over on our discussion board. Basically, what both of these kind of questions are asking is there a way that science can prove that God did or did not do something, right? If there's an explanation offered that God did something or did not do something, how can science prove he did or he did not do it, right? How can science deal with that kind of explanation? And I think what it sort of comes down to is another issue is this question, right? Can you guys imagine a science experiment that can prove that God does exist, or a science experiment that proves that God does not exist? Okay. In my imagination, I'm thinking of a middle school science fair project where this kid's got his little poster board there, and he says, if you mix these two chemicals together and they turn purple, God. But if you mix them together and it turns green, no God. Woo, and you win the science fair and all the science fairs forever. What can science do with that kind of explanation? Okay. All right, so I ask you these questions just because I want you to, I'm hoping, while you're listening to this lecture, you'll pause it for a second and think, okay, how do science and religious explanations deal with each other? And like I said, I want to try to have a discussion about this over in the discussion posts. But, my personal feeling on this so far is with the discussions I've had in class are that these religious and scientific explanations are different, right? They function differently, they rely on different foundations, and they are often not directly compatible, okay? So my suggestion to you guys is that in most cases, though you may be able to come up with some exceptions to this, is that I think usually science does not directly disprove supernatural explanations, right? Like, I think it would be hard. I'm having trouble right now imagining a test to prove God didn't place fossils in the ground to trick you, you know, or that he can't be controlling biology, you know, or that he does or does not exist. But again, that's my invitation to you guys, is let's talk about that and see if you can give me some ideas where I may need to tweak this slide. If you can give me some good examples that might work for some of these questions. Because what I think we're going to see, you know, in my lecture explanation and in your readings is that science is limited in a very important way. Science, by definition, can only use natural evidence and natural explanations, right? Science can't use supernatural explanations, it can't use supernatural evidence. So it's self-limiting. And it says, okay, I can deal with natural stuff and work through and give you an explanation for that. But when you present it with a supernatural explanation, scientists are like, sorry, man, that's not my stuff. I can't go there, okay? And it can offer alternative explanations, you know, for what's going on with those fossils, but sometimes compatible explanations, right? That would be in this realm here, that God and biology can go hand in hand and can work together. But I think a lot of times they're just on separate foundations and in separate realms, okay? So, and with this last point, you know, I think if people in this country understood this last point a little bit better, they might relax a little bit about all this fighting they're doing, right? Again, right now, while giving this lecture, I can't think of any way that science can prove or disprove God. So, but you guys may be able to give me other ideas in the discussion. But I think, you know, if you signed up for this class and, you know, your grandma, your abuela's freaking out about you taking this and thinking you're going to hell, I think tell her, relax, grandma. Science really can't, you know, disprove religion. They're separate things. They're separate realms of human explanation. I just don't see the reason for most of the conflicts that people sort of bring up and hype up with these two explanatory systems. Okay. But again, I want to talk about it more in the discussions. So let's play with these ideas and tell me if you've come up with some ideas for any of these ways that science and religion, you know, interact with each other, and let's talk about it and see how that goes. And remember, in the discussion post, be respectful of each other, right? Again, you know, I'm not looking for anybody to, you know, prove that they're right and everybody else is wrong. You know, I'm talking about these explanatory systems and how they can and cannot interact sometimes, right? I don't get anybody to get into, you know, personal conflicts over there. I just want to talk about these ideas and see how it goes. Okay. So, and you know, like this idea here in the middle about God controlling biology, this is often this is a pretty mainstream religious viewpoint, okay? So if your, you know, grandma who's freaking out about this class is Catholic, or you know anybody who's Catholic, you can remind them of, there's this guy, the Pope, Pope Francis in particular, right? He has said this multiple times of Catholicism and evolution can get along just fine, right? They're not in opposition, you know. He's suggesting that kind of, you know, explanatory framework of, you know, yeah, biology works, you know, that's how God runs things, is through biology. Okay? It's not surprising that Pope Francis would be saying this because he's got a background in science. So he's well trained in science. Before him, Pope John Paul back in the 90s, probably before you guys were paying much attention to popes, he was saying the same things. It's like, chill out. Everybody who's Catholic can get along with evolution just fine. But if you're, you know, not Catholic and a different type of Christian, you may have a different background than this, and this won't mean anything to you. But religion and science can get along, you know, and I think they should get along a bit more than they do sometimes. Okay, so I just wanted to give you that as background. And I wanted to say that because I'm using this, now what I'm gonna do is I'm gonna shift into some course materials here and start lecturing on things that you've got in your readings. I'm gonna give you a little bit of a background, a history of evolutionary thought. I'm gonna give you a little overview of some important ideas before Darwin came around, and I'm gonna give you some ideas that led up to Darwin's theory. So that's the plan at the moment. Okay. So, you know, in my slides just a minute ago, I was saying, hey, religion and science can get along sometimes. I think they can, but sometimes they do have alternative opposing viewpoints, okay? So I need to bring out a few significant, important religious ideas and explanations that were around long before evolution that are very different than evolutionary theory. All right, so let's do that. Okay, the first idea is it's this concept that it has different names, but I think this from your textbook talking about, it's called the Great Chain of Being. What this is, it takes different forms in different religious traditions throughout history, but it is the idea of ranking living species from, you know, worst to better, right? Or better to worst, or, you know, perfect to imperfect, that kind of thing, right? It's a hierarchy value judgments of species, right? Saying those species, they're gross and they suck. These species are okay. These ones up here are awesome. And that species at the top, it's the best, okay? So take a guess, which species ends up on top of this kind of list as the best species on the planet? You may not be surprised to find out that when people rank things from worst to best or imperfect to perfect, humans tend wind up on top, okay? Is that humans are perfection, right? Humans are the best species on the planet. They're the most perfect, the most divine, the most godlike, the most pure, whatever your, you know, value system is for judging this, okay? So again, this concept has been around for a long time in a lot of religious traditions, basically saying humans are awesome and humans are the best. Okay, so the issue here is that, okay, fine, humans they're certainly fancy. We're gonna spend like a whole month talking about humans because, but the idea that humans are sort of more perfect and necessarily better than all other species, that's not going to fit in too well with what we're doing in this course. Because, okay, take the average human, right? Anybody in our class, right? If you take a human right now and transport them to the middle of Antarctica, how are they going to do? Drop anybody in our class, boop, there, drop you right there in Antarctica, go. It's probably gonna suck. Fortunately not for very long because you'll be dead quite quickly, right? in that context, in the middle of Antarctica, being a human maybe isn't the best thing to be, right? It might be better to be a penguin in that situation, right? They seem to do a bit better in that habitat. Or another example, take your average human right now and suddenly, stick them a mile under the ocean, a mile down in the sea. How are they going to do? Again, pretty much instantly dead, okay? In that situation, again, it doesn't seem to be best to be a human in that situation. That's not the most perfect species to be there, okay? There are plenty of deep sea ocean creatures that are gonna last much longer than a human. So that's what I'm getting at here, right? This sort of uncritical view of humans as the best in all circumstances doesn't fit with what we're going to do this semester, because we are going to be looking more at how specific species are suited to their specific settings and environments, right? The idea of it's better to be a penguin in Antarctica than a human, that kind of thing. So this religious concept was around for a long time, and it doesn't fit well with evolutionary theory. Okay, there's another religious concept, again, that goes by different names, but it's this idea of the fixity of species. And what I mean by that is, this is the idea that all life you see around you on Earth exists as it always has, right? Nothing ever changes. A squirrel today is the same as a squirrel yesterday, is the same as a squirrel, at the beginning of time, a squirrel is a squirrel is a squirrel, right? Nothing ever changes. So that idea also, it's understandable, given that human lifespans, 70 years or so, yeah, squirrels don't change much in 70 years. So humans never really saw much change in anybody's lifetime, okay? So they just assumed, well, things have always been the same. Squirrels have always been the same since I was a kid. They must have always been the same since the dawn of time, right? It's that idea. But in terms of biological evolution, if nothing ever changes, then I have almost nothing to talk about this semester. Because the whole semester is going to be about change. So change is an important concept that does not fit with that specific religious idea of no change. Okay, then there's another religious concept that you guys are probably relatively familiar with, and this is the idea of the age of the Earth. And again, this takes lots of different shapes and forms in different religious traditions. But one of the things humans like to do is imagine and come up with explanations and stories for how long things have been around, right? When did it all start? And it varies in different religious viewpoints. But the one we're dealing with here is sort of the idea that things haven't been around for very long. And one of the versions of this that you may be most familiar with in sort of the Western European tradition of things is comes from this guy, this bishop in the 1600s, Bishop Ussher, right? And he wanted to figure out how old the Earth was, right? When did it all start? What was the beginning? So he's a good Catholic bishop, right? So what is his main source of evidence? For him in the 1600s, it'd be the Bible, right? So he went to the Bible and started researching, right? And he used Genesis. And what he did was he looked through Genesis to find basically the oldest historical figure that he knew the date of, right? And then he traced the lineages. He wrote out all the lineages and counted backwards, right? So he read all those sort of dry, boring chapters of, Isaiah beget Jedediah, beget Methuselah, beget who, and all the families, lines. And he took into account lifespans, because some of those Old Testament patriarchs lived for a long time. So he worked out all the family trees and all the lifespans and did calculations to figure out all the way back to Adam and the Genesis story, the creation story in Genesis, and figured out that using those calculations, he calculated that the earth was created in 4004 BC. He got even more specific than that. He got very specific. He nailed it down to, he thought it was around the 22nd of October, 4004 BC at around 6 p.m. is when creation first happened. So he put a lot of work into that, okay? So his calculations are basically saying the earth is about 6,000 years old. Other people have revised his theory and tweaked it. And like I said, you see different versions of this, but they tend to hover in the range of the earth being 5,000 to 10,000 years old. Okay. So that is a religious viewpoint and a religious explanation for the age of the earth. This one, again, this idea is not going to be very compatible with what we do in this class, because if the earth is only 6,000 years old, yeah, that's not enough time for anything to change. So actually, young earth and Fixated species make sense because nothing can change in 6,000 years. That's like a blink of an eye. And again, if the earth is only 6,000 years old, I don't have much to talk about this semester. So these ideas, these very specific, concepts based in religious tradition, these were around for some of these thousands of years before evolutionary theory came around. And they were, you could say obstacles, to an evolutionary understanding of it, because these specific ideas are in sort of direct opposition, right? Not necessarily religion as a whole and science as a whole, but these specific concepts do not fit with biological evolution. All right. So that's a little background in some of the religious theories we'll talk about slightly this week and next week. Okay. But then what we're going to get to is what's called the scientific revolution. Okay. In Europe, this is happening during mostly the 1500s and 1600s and a bit in the 1700s. Scientific revolutions are also happening in other parts of the world and other cultural traditions at other times. But this is just mentioning the European one because that's the one that's most relevant to Darwin, who we're heading towards talking about. But there's other scientific revolutions going on around the world that are not just in Europe. So pardon this slide being slightly racist and focusing on Europe. But during these scientific revolutions, these are where sort of our modern ideas of science begin to take shape. And there are new methods being used here, okay? Okay, so this is a very important slide that I'm going over today, right? Is what I want to explain to you is the scientific methods that are used in anthropology, biology, right? Because again, whether you realize it or not, when you signed up for this class, you're in a science class, okay? This is science. Everything we're doing this semester is science. So that's why I need to take a moment in this first lecture to review the scientific method and sort of how it works. Because this is what we're doing here in this course. So, and I'm presenting this because I want you to recognize what science is and also what it's not, okay? And I think that's a useful life skill, is to just be able to separate those two in your mind, is to see something and say, oh, that's science. See something else, be like, nope, not science. It's a different kind of explanation. And again, there are other kinds of explanations out there. I just want you to recognize the kind we're dealing with in this class. All right, some of you, depending on when you took your high school science classes, you may remember the scientific method from high school. You may have vague, fuzzy memories of that. maybe there was a poster up on the wall about the scientific method. If you do remember being taught the scientific method, you were probably taught it in sort of the singular as the method. That's a slight simplification, a slight oversimplification, and that's true for most of the stuff you learned in high school. It was probably an oversimplification or completely wrong. But hooray, you're in college. Now you get to learn better stuff. But the scientific method that you learned in high school is correct. It's just slightly simplified because the different sciences, like chemistry and physics and astrophysics and quantum physics and organic chemistry and biology, they have slightly varying methods depending on what they're looking at. But I'm going to go through the methods seen here that we typically see in anthropology, and you'll recognize them as, broadly speaking, the same methods you probably learned in high school. Okay, so everything starts off with an observation, okay? Noticing something that you see or that you read that's interesting and catches your attention, right? And it creates a question like, what's going on there? Why did that happen? This is sort of common in being a mildly caffeinated, awake human being, right? You notice things. And they create questions in your mind, like what's going on there? That's the starting point. It's just something interesting happening. I think it usually works best to explain this slide if I give you an example. So let's see. Back in the before times when we used to be able to go out of our house and go out and do stuff, I used to go to the zoo. The zoo's actually still open. You can go to the zoo. But okay, so I go to the zoo whenever I can on years when I can afford a membership because it's freaking expensive, but that's a different issue. So I like to go to the zoo. I am a primatologist, so I like to go see the primates. That's one of my favorite things to do. I'll go check out the orangutans and the monkeys and go see the gorillas. If you have not been to the zoo, you should go, find a rich friend who has a membership and get you in. But this is a good place to go. Okay, so I'll go to the zoo and I'll go look at the primates, and go watch the orangutans and go, check out the gorillas. And then usually what I like to do is after I've watched the gorillas, back when there were lots of people at the zoo, I would then step back from the window, all the short people behind me were like, oh, could you tall bastard finally get out of the way so my children can see? So I would step back and then listen to the people talk about the gorillas, okay? And I'm an anthropologist. I'm allowed to, pay attention to people and listen to them. It's not too creepy. I can just say that's what I'm supposed to do. But I'll listen to people talk about gorillas. And if you hang around the gorilla exhibit for a while, what you will start to hear is a lot of the same things come up again and again. And if you're there and there's people around, you'll hear these things, is people will make comparisons between the gorillas and somebody they know, right? They'll say, hey, that gorilla over there, that looks like Dad, or they'll say, oh, look what he's doing, you do that too. They'll make all these conversations, these observations about how gorillas remind them of somebody. Something the gorilla is doing is very familiar to them. Okay, so that's interesting. I think that's interesting because I hear it all the time, okay? And what I find interesting is you hear that a lot when you're around the gorillas, but if you ever go to, the giraffes, I don't usually hear people say that about the giraffes, right? I haven't heard anybody say, that giraffe reminds me of you. Look, that's what you do when you're watching Netflix. No, people just don't say it, right? And I've never heard anybody say it while they're looking at the crocodiles, and say, oh, that crocodile looks like no. So that's interesting, people notice that similarity that we have with gorillas that they don't notice with other types of animals at the zoo. Huh, interesting. Okay. So that was a long little tangent to say, you notice something interesting. Okay, now where you go from here, that can vary a bit, right? You could go in different directions from this point, okay? But for the purpose of this class, what I want to say is if you want to go in the direction of science, then step 2 here is extremely critical and very important, okay? To head in the direction of science, the next step is the formation of a hypothesis, okay? And a hypothesis is something very, very specific, okay? And what I want to stress here is a hypothesis is not a guess, okay? And probably in high school, did you guys learn that a hypothesis is an educated guess? What is that? Is it a guess with an associate's degree? Does it have to have a bachelor's degree to be an educated guess? Like, educated guess is one of those sort of fluffy nonsense high school words that doesn't mean anything. So it's not a guess. What a hypothesis is a testable and falsifiable prediction about how to answer the question and explain the observation. Okay, so let me give you an example here. If you notice, like, that's weird. There's a lot more similarity between gorillas and humans than humans and giraffes. Why is that? There are different ways to explain that. You could suggest an explanation saying, well, I've read the Bible, I remember Genesis, maybe it has to do with creation times, right? Maybe it's the order of God's creation. He starts with fish and birds and then works his way up to land animals. Maybe as he's making animals, the last one he makes, he makes in his own image, and that's people and all, they're fancy and wonderful. Maybe he made gorillas right before humans, right? And he was making things more and more like him as he went along. Gorillas were right before. He made a gorilla, looked at it and said, looked in the mirror and said, kinda, but I'm not really that hairy. So let's see, shave a gorilla, make it stand up a little bit more, right? Oh, they're human, right? It's a weird example, but the idea is, an explanation would be, gorillas were made, relatively late in creation, and that's why they look more like us. They were made right before us. That's an explanation. But that would not qualify as a scientific explanation because it doesn't meet these criteria of being testable and falsifiable, right? Is there a way you can test the idea of when God created different species? Right? Can you test and see whether he made giraffes first or gorillas first? And is there a way to prove that, to disprove that idea and say, no, it cannot be that. It's not that God made gorillas right before humans. This goes back to the religion slide I was talking about before. I don't think there's a way to test and disprove that, at least scientifically. So that idea is an explanation, but it's not a scientific explanation, right? So it wouldn't be an explanation we'd be able to use in this class. For the purposes of this class, right, for science, you could instead suggest the idea that, well, why are humans and gorillas more similar than humans and giraffes? You could suggest, well, maybe it's because humans and gorillas are more closely related than humans and giraffes, right? That's why they're more similar. It's a family similarity, right? And we are distantly related to giraffes. but closely related to gorillas, so there's a lot of overlap there. And that's why people recognize all of that overlap and similarity. That's why they're so much more like us. Okay, so what I want to suggest is that that idea of a shared family connection, we're more closely related to gorillas, is a scientific hypothesis because you can test it and it's set up that it can be disproven, okay? All right, so to test and try to falsify a scientific hypothesis, once you've posited, once you've suggested it, said, I think it's a close shared relationship, then you have to test it, right? That's the whole point of science, is testing these ideas, testing these hypotheses. So step 3 in the scientific method is data collection. You have to go get evidence, okay? Collect facts and observations to test your hypothesis, all right? And I'll mention here, right, the methods have to be clear because everything in science needs to be repeatable. Other people have to be able to collect the same evidence that you do to sort of check and see that you're doing it right. And this is probably where in your high school classes, in the poster of the scientific method, it would say, do experiments. In some of the branches of physics and chemistry, this is where they do experiments. Anthropology, not as much. It's not as much an experimental science as an observational science. So this is where the methods vary slightly. There's a few experiments in anthropology, just not usual. It's usually collecting facts and observations. Okay. So we need evidence to test the idea, the hypothesis, to see if it's a scientific hypothesis. Test the idea that humans are more closely related to gorillas than they are to giraffes. So this is what I want you to do over in the discussion board. After this is, what kind of data would we collect to test that idea? Okay, what kind of data, what kind of evidence do we need to test that hypothesis about a shared relationship with gorillas? So when you get a chance, before you forget, head over to the discussion and suggest some ideas of evidence for this step. Okay, so we'll talk about that in the discussion. And what you're doing when you collect the evidence, once you've collected evidence, is now you need to interpret what that evidence means, right? You got to test it and analyze it, okay? So in science, your data has to be in measurable quantities, right? It's something they have to be things you can measure and compare, right? Because you're going to run statistics on it. Everything in modern science is statistics. So if you're planning a career in science, go take that stats class, you're going to need it. And what you're doing is, in these measurements and comparisons, you're trying to see, do the results fit the prediction you made, right? Because your hypothesis, our hypothesis that humans are more closely related to gorillas than they are to giraffes, sets up some very specific predictions, right? It says, it predicts specific things about the evidence you're going to find, right? And that's how you're testing it and seeing if you're right or wrong. Is did your hypothesis predict the right things about the evidence? So again, we'll talk about that in the discussion post. As we'll work through some ideas about what evidence is and how you're going to measure it. But these important steps, step 3 and 4, this is what I think you can't usually do with like a religious explanation, saying, oh, God made gorillas right before he made humans, and giraffes were sometime early in the morning, so they were totally different. Science has to be testable. So I want to talk more about data and analysis in the discussion board. So give me some ideas over there about how you want to test that idea of shared relationship. Okay, so we're going to talk about that. Those are the basic 4 steps of science, right? Observation, hypothesis, data collection, and then testing and analysis. Ideally, what you'd like to do in good science is to repeat this process again and again, right? Because getting one set of results, that's nice, you know, but if you get verification 10 times, 50 times, 100 times, it gets stronger the more times you can repeat it and vary your data and analysis a little bit here and there. Okay, so repeat it a bunch of times. And then with the scientific method, what you're building up towards, right, at the end is sometimes sort of the pinnacle of science. Where you can head is the formation of a theory. Okay? And a theory, again, is a very specific thing. Okay? And the wording here is important, right? What a theory is a tested, past tense, explanation that is supported by evidence. Right? And again, a theory is not a guess. It has nothing to do with a guess. It's a very specific thing in science, right? So notice this, right? A hypothesis is something you can test, right? A theory is something that has been tested and has evidence to support it. And most scientific theories usually incorporate multiple hypotheses within them, right? And this is important to bring up theory because the English language sucks. There's a lot of problems with the English language. One of the problems is this word theory. It has multiple definitions, okay? And I am sorry if any of you are ESL or learning English as a second or third language. Do not envy you. It's a tough language to learn because of issues like this. Theory has multiple definitions. Within the realm of science, in the context of science, theory means exactly this: a tested explanation that is supported by evidence. It is the culmination of the scientific method, okay? The problem is, outside of science, in everyday English, common English usage, what does theory mean? Theory means guess in everyday English, right? People use that all the time. Like, oh, I've got a theory about this, la, 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 la. You know, I have an idea, I have a guess, I have a theory. It's valid to use it that way in everyday English. But it is the exact opposite meaning here in science. It is not a guess. So this confuses people, particularly Americans who do not tend to have good science educations, right? Way too many Americans do not have a good understanding of science, okay? You know, they don't remember that poster from high school, and that was the last time they ever took a science class. So what happens is when they hear about, you know, a scientific theory, you know, their response is, well, yeah, I got a theory of my own. No, you're confused about the words. You know, I wish there was a different word here in science, you know, that they just didn't use that word because it confuses too many people. If you don't recognize that it's used differently in science, you get confused about what a theory is. And a lot of people do. And that causes a lot of trouble. So within science, this is what a theory is, right? A tested explanation that is supported by evidence. So I hope you're clear that when we're talking about scientific hypothesis and scientific theories, we mean very, very specific things. So I think I should explain a couple things that usually come up in questions in class when I talk about this. One is, what is the difference between a theory and a fact? Is a theory a fact? Can a theory become a fact if it gets better proven? That's an important distinction. Theory and fact. A theory is not a fact, right? A theory is something very different. Look up here in step 3. There's your facts. Facts are evidence, okay? I'll give you an example. You see this pencil, right? What happens if I let go of this pencil? It fell, okay? That is a fact. The pencil fell down when I let go of it. That's what a fact is. Now, why did the pencil fall? Gravity. The theory of gravity explains why the pencil fell down and not up. Theories explain facts. Theories are bigger than facts. Facts just are. They're the little pieces of evidence. They're like, that happened, you know, that's that way. Why they're that way, that's what the theory is. So theories are bigger than facts. They explain facts. They're different. Another question that comes up sometimes is the idea of what's the difference between a theory and a law? Laws you don't see come up in anthropology very much. They're rare in biology. Laws tend to pop up in chemistry and physics. What those are is usually interactions that you can write as an equation. If you can boil it down to an equation, you know, E equals mc squared, you know, that kind of thing, then it gets called a law. They're usually smaller in scope than theories, and they're, you know, smaller scale interactions. Sort of in a vacuum, A plus B will always get equal C, that kind of thing. So theories are usually different than laws in most of the ways we're talking about it in science. Okay. So that's important to know. Oh, it's also important to know. Can a theory be wrong? The answer is absolutely yes, okay? Theories can be wrong. Theories are wrong all the time, right? There are good theories, there are bad theories, there are weak theories, there are strong theories. Theories can be proven wrong. There always has to be a way to prove a theory wrong. Because look back here in step 2 with hypothesis. Theories are built on hypotheses, and hypotheses have to be falsifiable. Means there has to be a way to prove the hypothesis wrong. I hope to give you some examples of that in the discussion board when we're talking about hypothesis for human and gorilla ancestry. But hypotheses can be proved wrong. What proves them wrong? Evidence. Little things like facts, right? Letting go of the pencil and it flying up, that kind of thing. Evidence can prove hypotheses wrong. When hypotheses get proved wrong, the theories that are based on them get proved wrong, okay? So theories, you know, fall all the time. The history of science is littered with theories that looked good for a while and then collapsed. So they come and go. But still, in science, theory is the pinnacle of the explanation, right? That's as good as it gets when you've got a theory. And I'll point out, when we're talking about in the context of this course and this semester, the theory of evolution, right? That's what we're going to be talking about. The theory of evolution is one of, if not like the strongest large-scale theories we have in science. It is massive, it is huge, and it is about as rock solid as you get in science, okay? It has been around now for 150 years, going through constant and rigorous hypothesis testing and falsification tests, and it is still standing. Does that mean evolutionary theory is a fact? No, facts are different, right? Can evolutionary theory be disproven? Sure. All scientific theories can be disproven, right? All you need is the evidence to disprove it, right? Evidence can disprove scientific theories, right? You find, you know, the fossils of a bunch of humans or modern animals, you know, like pandas, you know, 500 million years ago, before they should be there. that's going to be a problem for evolutionary theory, right? So evolutionary theory may collapse at some point in the future, you know. Fingers crossed, it makes it through the semester, so I don't have to rewrite all my slides. I think it's going to make it the rest of 2020. It'll make it through the semester. It's made it 150 years. I just needed to make it 4 more months for this class. But I don't make promises that it won't collapse someday in the future. Just right now, it's one of the best theories we've got going on in science. So I'm sticking with it this semester. As far as I know, it'll make it through. All right. So that's what I want to go over in this lecture is science. I want you to be able to recognize an explanation has to fit these criteria to be a scientific explanation and a scientific theory. If it doesn't fit this criteria, then it's a different type of explanation. It's just not a scientific explanation. And everything we're dealing with this semester is going to have to be a scientific explanation and fit into these methods. All right, I hope that makes sense. Ask me any questions you want over in the discussion post after you've watched this. Okay, so those are the slides I wanted to cover today. So I'll just give you a reminder now. This week, what I want you to do is go talk about these ideas in the discussion posts and questions, right? Talk about that slide I was talking about with, you know, what could prove God didn't put fossils there to trick you and God being part of biology, and can science prove or disprove God? Talk about that. In the scientific method, talk about, you know, this idea of humans are more closely related to gorillas and giraffes. What kind of data would we need to test that and prove that, right? How do we know that's a scientific hypothesis? How would we proceed with that idea? To do that, and I'll talk with you in the discussion this week about that. Make sure you've read chapters 1 and 2 of the textbook. That's the reading for this week. Use the beginnings of this lecture and what you've got in the textbook to start working on your first exam answer. Don't forget to sign up for 2 group presentations this week using that Google Doc link, and post your introduction video so I can meet you guys and get to find out who you are. And then for next week, week 2, if you haven't already, you know, if you don't have your textbook yet, make sure you've read chapters 1 and 2 of the textbook by the beginning of next week. So get that done. Next week, there's 2 articles to read. The first 2 articles on the facts of evolution and creationism. Be ready to write your answers for the first 2 exam questions, because your exam will be due at the end of the 2nd week. All right. Congratulations, you've made it through your first biological anthropology lecture of the semester. That's all I've got for you. I will see you over on the discussion board to keep talking about this stuff. See ya.